I think some of you guys know me already. I'm John. I'm one of the CA3s, and we're going to be talking about ventilators. We're talking about ventilators with Dr. Kukrija. He'll be doing your guys' PBLD this afternoon. So if there's like really a lot of questions or any things that you guys wanted to talk about after, that'll be a really good time too. But we'll have hopefully some time for questions after. So when I was going over, how are we going to teach you guys the ventilator? How are we going to do it the best? I was like, well, what better way than to actually like have an image of the ventilator and to actually go through each of the individual parts. So what we'll do is we'll kind of talk about each thing, and we'll kind of start up here. We'll kind of wrap around all the way around, and we'll just go through each individual part. And we'll talk about kind of what the settings you guys should typically put these at, what the major concepts are, and then maybe some major test questions that you guys will frequently see on your board exams, okay? So we're going to start here. And so this here is your little airway pressure gauge. And you can see it starts at 0 here, and that has it also goes negative for when the patient's inspiring, but also positive for when you're giving positive pressure ventilation, okay? So it measures instantaneous pressure at any time. Whether you're on the bag or on the ventilator itself, it's going to show you it instantaneously, okay? And I'm going to ask questions, and anyone who feels like they know the answer, feel free to blurt it out. So what is the maximum airway pressure during mass ventilation to prevent gastric insufflation? What do you guys think? So on that pressure gauge, you're going to squeeze it to a certain amount, and you don't want to go over this amount, right? And it's 20. Yeah? You guys know these. Don't be worried. I'm a resident just like you guys. So yeah, it's 20. You don't want to go over 20 because what happens is you open the lower esophageal sphincter and you start to insufflate the belly, the stomach, and then the concern is that you'll get an aspiration pneumonia. So when you turn that APL valve, when you start masking, when the patient stops breathing and you need to mask them, set that APL valve to 20 and you shouldn't go over that, okay? At least when you intubate, all right? I mean, at least when you're masking without a protected airway. So what are the concerns of administering high airway pressures? What are some of the things you think might be bad stuff that might happen?
Barotrauma.
Yeah, barotrauma. And what are those? What does that potentially look like? So some of the things.
Pneumo.
Yeah, pneumo, exactly. So you might get a bronchopleural fistula. You might get a tract that shouldn't be there, a tear in the lungs that eventually develops air into the pleural space or a pneumothorax or pneumomediastinum. And that's why we aim to keep pressures lower, not like excessively high, right? So what are and that kind of talks about the concerns of administering high airway pressure. So what is the maximum peak airway pressure that you shouldn't go over, that we generally keep patients under?
40.
Yeah, 40, exactly. Very good. So you want to keep them under 40, and we'll talk about peak and plateau pressure a little more so that you guys understand what that even means in the first place. But yeah, you generally don't want to administer breath, especially when on the ventilator, higher than that 40 mark, okay? And generally, I shoot somewhere around 30, 35 area when I'm ventilating patients and I'm struggling. I generally keep them around that area, Okay? So that's the pressure gauge. So then you have here, you have your, this flow, and it's measured in liters per minute. It's divided into your oxygen, which will always be there, and then you'll either have here air or nitrous oxide, and it's going to be colored to the US standard of gas colors. So green is for oxygen, yellow is for air, and then sometimes you'll have nitrous oxide on here, and it'll be blue over here, okay? And then, as you can see, you've got it split, and so the split will be determined by what you set your total flow to. So if you set it to 6, and it's 50-50, so you'll have 3 liters on both sides of these elevated, okay? So let's talk about that. So what are the benefits of a low gas flow rate? What are some things that you guys think might be beneficial to the patients of going low flow?
Breathe some of that anesthetic gas.
Right. So yes, exactly. So one of the things is you can save on the amount of anesthetic gas you use. If you're setting high flow rates, a lot of that gets wasted outside of the machine. If you're setting really low flow rates, then you rebreathe some of that anesthetic gas, okay? Versus if you're setting really high flows, you're putting new gas, like new oxygen, new air in, and a lot of that gets blown out of the machine, okay, and wasted. What are some other things you guys might think about? I mean, you're pretty much connected in a circle system. The patient's rebreathing a lot of it. What do you guys think is happening to the air? Is it cold? Is it warm?
It stays warm.
Yeah, it stays warmer, right? And what about the humidity? It stays higher, right? So that's the potential benefit of not putting a ton of new gas in, is the air stays warm, it's humidified, the patient stays warmer, and they get, their lungs don't get exposed to just really dry air all the time, okay? What are some of the risks of low flow? So we talked about the benefits. What are some of the concerns?
Is it higher risk of like anoxic air?
Not necessarily that, but I mean, it is a potential. It is a potential if you're really going low flow. We'll talk about that a little bit more.
On longer cases, we were talking about compound A and sevoflurane.
Very good. Very, very good. So you can have accumulation of toxic compounds. And again, compound A is a debatable one. We'll talk a little bit more about it. But you can have accumulation of carbon monoxide in smokers. You can have accumulation of alcohol in alcoholics who recently drank. You can have accumulation of acetone in people in DKA. And so that's something. So if we really want to prevent that, this general recommendation is about 1 liter per minute is the amount you'll need to prevent rebreathing any of those gases specifically, okay? So what is the maximum amount of flow or O2, the minimum amount of flow or O2 needed for an adult? So this is measured in mils per kg per minute. You guys, this is a little bit more advanced, but it is a common question you'll get asked in the OR. So what could we potentially turn the flow to, the lowest amount we can possibly go, and how do we decide that?
One of our tunings told us the other day that you consume like 3 cc's
Yes,
of oxygen per
it's
kilo.
3. So you guys remember that? It's 3 cc's per kg per minute. So that's the minimum amount of oxygen an adult would need to breathe in order to maintain a standard metabolic rate, okay? And not have anoxic brain injury or things like that. So you need at least 3. But for children, what do you guys think? I mean, of course, you guys haven't done peds yet, but I'll tell you. It's 6. So kids have a higher metabolic rate than adults, and so they need a much higher amount of oxygen. So if you were to do a really extreme low flow system, you would need to consider this as the minimum amount of oxygen you need to add back into the system to oxygenate the patient, okay? So what is and these are debatable, but what is the minimum flow rate for sevoflurane, isoflurane, and desflurane? So you have these on your machine, they're turned on, you're using sevoflurane, let's say. What are you going to set your minimum flow rate to? And you talk about compound A, but what do you guys think? What do you guys typically set it to?
2.
Yeah, a lot of people would say 2, right? And a lot of studies, they're saying, well, there's a concern for accumulation of compound A with sevoflurane. Compound A causes nephrotoxicity in animals, but they've never shown this to be a complication in adults, okay? So some people would argue you can do 1 liter per minute with sevoflurane as well. So 2, 1, I'm going to tell you that most attendings I work with, they prefer you just leave it at 2, okay? How about isoflurane and desflurane?
This is probably a little lower.
Yeah, this one probably can be lower because you're not concerned for compound A. You could probably typically set it to 1 liter per minute. But don't forget that you're going to have to take into account the accumulation to get to a MAC, right? So you're going to have to increase your flow rate initially to get your gas to the level you need it before you go down on your flow rates, right? Because it does take a while, especially with ISO, you're going to want it to build up much quicker. So you're going to need to keep a little bit higher flow at that point. These are really common board questions here. So what is the effect on anesthetic delivery if you have really ultra low flows, let's say less than 250 cc's per minute? What would you guys think? You're trying to get anesthesia to someone and you have super low flow rates. Would your delivery of anesthesia go up? Would it go down to the patient? What do you guys think?
Might go
Yeah, it'd go down. You're not moving enough air to even get it through the circuit fast enough to really get it to the patient. So your anesthetic delivery will go down, okay? But what if you have really high flows? What if you have greater than 15 liters per minute? Like you can't even set this on the vent, but what if you could if you went above 15 liters per minute? And this is compared to that 1 to 15 liter.
Also would go down.
It would also go down, exactly. So when you increase your flow, let's say from 1 all the way up to 15, you increase anesthetic delivery to your patient because you're getting the flows, you're getting the anesthesia to the patient faster. When you go over that 15 liters, you start to actually dilute the gas. A lot of the gas doesn't even reach the patient because you're flushing it out of the system before it even gets to them, okay? So these are common board questions for you guys, all right? So you guys hopefully feel a little more comfortable with the flow rates, okay? So then down here, you have on this little tab here, you have your fresh gas, and it just tells you, what you're using, O2 plus air usually. And then you have your FiO2 that you can set. When you click on it, you can either turn the knob to adjust your FiO2, or you can select a pre-select amount in the tab to set your FiO2, okay? When you select total flow, same thing. You can adjust the knob to adjust your total flow, and this is what we're talking about a lot about with the flow. And you can select a pre-selected amount, whether it be 0.51 or anything like that, okay? Same thing with your anesthetic gas. So depending on what you have in your machine, you can either turn the knob to adjust it or select a pre-made amount, okay? And then something I wanted to show you guys is the gas setup button. So you guys probably haven't clicked on this much, but you can see here, the main thing I wanted to point out is a lot of these we've already talked about. This should say SIBO. But here, on your other gases, there's air. If you select that button, and you can select it, and you can select nitrous oxide. So in case you guys ever want to switch the air out for that nitrous that I was talking about. And you'll get more comfortable, and you'll start using nitrous a little more in the future. Because you guys will notice there's no nitrous canister or anything like that. It's in one of the tanks, and you have to select it from this to get there, okay? All right, so let's talk about the different vent modes, okay? So you guys probably feel already a little comfortable about a lot of these from when you guys were medical students, but I kind of have, we'll kind of just talk over them just to get everyone on the same page. So when I think about these vent settings, I think about them in terms of invasiveness. How much are you supporting the patient? And so pretty much from top to bottom, you have your control settings, your volume control or pressure control, and then you have your pressure control volume guarantee, which you guys have probably already started seeing on the vents, but are probably like, what in the world is that? And then you have your SIM-V, and then, which is, I'd say, an intermediate in terms of invasiveness. And then you have your pressure support ventilation, which I would say is the least invasive, okay? And we'll go through each one of these, all right? So in terms of volume control, so how this works is, you set your tidal volume, you set your respiratory rate, and you set your IDE ratio. And we'll talk about that a little more in a little bit. But the key thing in a volume control mode is that you have a constant flow when you are inspiring. You see that? So it goes up, constant flow, down again, take a breath, constant flow, versus your pressure is going to be variable, okay? And that's kind of how you can distinguish it. And with volume control, with the control mode, you're always given the breath. You're going to be given the breath, and if you try to initiate your own breath, the machine's not really going to do much for you. It's actually probably going to resist you, and patients often cough or buck when that happens, okay? Especially if they're not relaxed. With your pressure control mode, now you see things are a little bit different. So you set down here your inspired pressure that you want to achieve, right? Same thing, respiratory rate, IDE, and PEEP. And you see that the flow is no longer constant, right? It's kind of variable. And the pressure instead is constant pressure. So in pressure control mode, you have a constant pressure, a variable flow rate. And that flow is, of course, going to be highest at the beginning. That's why you have a really high flow at the beginning, and then it drops down because your lungs are more compliant when they're collapsed, and then when more air gets pushed in there, the compliance goes down and your flow goes down, okay? Hopefully making sense.
Just real quick on the pressure, but specifically on the pressure ventilation, you notice that the flow pattern slopes down every single breath, no matter what. It's designed to do a decelerating. This is the buzzword they like to ask on the ITE and AKT. It's a decelerating flow pattern, which is thought to improve gas exchange. So you will see the respiratory therapists switch very commonly in all settings. If they're not doing well in the volume control, their go-to becomes pressure control before they start calling and relaying up the ladder that this person's having a problem with gas exchange. But the decelerated waveform is thought to improve gas exchange. The problem is that your compliance changes throughout time, so you can't guarantee the volume you get. So you need pretty strict vigilance if you're in someone on that mode.
And then again, with control mode, mandatory breath. Try to breathe. Machine's not going to help you. You're going to be fighting against the machine, okay? So now let's talk about pressure control volume guarantee, because this is the mode that comes standard on your machine when you turn it on in the morning. And so you can see here, it's a pressure control mode, but a volume guarantee. So you set a volume, and that's kind of weird, right? Because this is a pressure control mode, you would think you would set a pressure, and then everything else is still the same. And the key thing is that the machine will try to adjust the duration of the breath and how long the breath is, how it administers the breath in order to deliver the volume you set it at, but it will do so once you achieve like stability with the machine. It'll give the breath at a constant pressure. And so that's why it's a pressure control mode, but it tries to guarantee you a certain volume by adjusting how it delivers that breath, okay? That's all it is. So then you have your SIMV modes, and if you can tell, the SIMV, so that stands for Synchronized Intermittent Mandatory Ventilation. And you can see it comes in all the different modes that we just talked about, right? You have your volume control mode, your pressure control mode, and your pressure control volume guarantee mode, right? And all it does, let's click on volume control. Let's say you clicked the volume control one. You set the respiratory rate, you set your volume because it's a volume control mode, and your respiratory rate. And what you do, what it does is it will try to synchronize it'll give mandatory breaths based on what you set. And then if the patient attempts to initiate the breath, it'll support them and allow them to do it, unlike the other mode where it kind of just suppresses it. And this can help prevent bucking and coughing sometimes. And this is kind of the mode I transition to when we're nearing the end of the case. You want to start getting the patient to breathe on their own, but they're not breathing on their own completely yet at all. So you still want to give them some mandatory breaths, but when they start initiating their own breaths, you're assisting them through that, okay? And so that's all the SIMV mode is, and it tries to synchronize the mandatory breaths to be not when the patient's breathing. It tries to. It doesn't mean it always does. And then you have your pressure support mode, which you guys are probably comfortable with by now. And the key thing with the true pressure support mode is that the patient has to initiate their own breath. So the machine detects a negative flow, and once it detects that negative flow, it doesn't look as pronounced as this. Then it gives a breath, and that's what, and it'll be pressure breath, so it'll be a little square, just like your pressure control modes, okay? But we have a backup mode, and it'll back up into SIMV if the patient's not breathing, and it detects that they're apneic for about like a minute or something like that, okay? So those are your different modes. So you can, of course, select tidal volume. You can adjust your tidal volume, respiratory rate, and then your IDE ratio is something that's probably a little new to you guys. Some of you guys might feel a little more comfortable with it, but the key thing with this is it's the amount of time you're spending in inspiration versus in expiration. So in this scenario, it would be like one second in inspiration, 3 seconds in expiration, depending though on how long your breath is. So it'll be the duration of the breath, and you can calculate it out. But the key thing I wanted to point out is, when would you adjust this? When would you change it? So normally ours is 1 to 2. So we spend about 1 to 2 in inspiration versus expiration, okay? So when somebody has a lot of compliance problems, if they're really morbidly obese, they're in steep Trendelenburg, they turn back and all that gastric content's pushing on their lungs, you're gonna notice that you got really high pressures and you're not able to achieve the tidal volumes that you may need. right? So in that situation, you want to spend a little bit more time in inspiration, and that'll give a slightly longer volume. It'll give it more time to administer the breath, giving you a slightly higher volume. And then the reverse is a scenario in which you have a patient with obstructive lung disease, such as COPD, asthma, things like that. And they're trapping air now. And so if they're trapping air, you want to give them more time in expiration. So you'll set an IDE ratio of maybe like 1:3, 1:4 in these types of patients to give them more time to exhale those gases. And the extreme of this would be auto-peeping, which is what you'll see is on the flow is that, let's say this is your 0 line. When you're about to inhale, this point here is when you're about to inhale, never gets back to 0. And it starts to get less and less than 0 because you're starting to build up that air in your lungs. Make sense? So that's what it looks like on the flow side. But on the PEEP side, the pressure side, it'll make a little more sense because you're auto-peeping, right? You're building PEEP with each breath. And so you can see the amount of PEEP, or peak end expiratory pressure, is building up with each breath. You see that? So it just starts stacking up. And that can result in high airway pressures eventually and problems with that. So giving them a longer IDE time will give them more time to get that air out. Okay? All right. And then you guys are, yeah. Okay. We're going to speed up. So PEEP, you guys are probably a little more comfortable with. The 2 ways to oxygenate is FiO2 and PEEP. The 2 ways to ventilate is volumes and respiratory rate. Okay. So something I want to mention here is your procedures tab. And I wanted to point out the pause gas flow. So when you disconnect your tube, when you're about to intubate, when you stop masking, about to intubate, you want to hit that pause gas flow just to prevent air from blowing into the room and things like that, okay? And then you also have your start cardiac bypass button, which you guys will use a lot when you're a CA2. And also you can use it when you're doing MAC cases and the alarms are just blaring. You can click this button just to monitor the CO2, okay? Next, I wanted to point out the spirometry. So you guys will see there's a spirometry button here, and then you get this, which is a volume versus pressure. But there's also a spirometry, there's also this spirometry over here, which is also a pressure, volume versus pressure. And so what I wanted to just point out is this spirometry is not the same as what we learned in medical school, okay? This is what you will get. This old one is what you'll get tested on board exams and the majority of your questions. But this is what you'll see on all our vents. And the difference is one gives you an idea of the flow and airway obstruction, the old one, and then ours gives you a better idea of airway compliance, okay, and pressures, okay. So you're never going to get tested on these pressure volume loops. I've never seen it on a board exam. But it's good to know that there are pathologies that you can identify using that waveform, but a lot of us don't use it. So peak airway pressures, so you have that little gauge there which shows that little area that talks about pressures. So you have peak airway pressure and plateau pressure. So what is the difference? And I'll just breeze through this because we don't have a lot of time. But plateau pressure, if you were just to look at plateau pressure, that is the amount of pressure that would be in your lungs with just some air in it, but it's not moving. You're not breathing or exhaling. It's just, you just give them air and you hold it there. And that gives you an idea of the compliance of the lung and the chest wall, because it's just staying still, okay? But when you have peak pressure takes into account the chest wall and the lungs, plus the effects of airway movement through the lungs, right? Because you're gonna have a lot higher pressure when air is trying to travel through the trachea and the bronchioles, and you're going to get a lot more pressure during that time. So peak airway pressure, we said we are okay up to 40, and plateau pressures, we're okay up to about 35, okay? Graphically, you got your peak airway pressure, and then, right, it's going to be much higher, and then if you held the breath, the pressure will come down, and you'll get your plateau pressure. So this difference is the compliance of the lung and the chest wall. And this difference between here is the airway resistance, okay? So that's the key thing. you can tell what pathologies you have based on if you have high plateau or high peak pressures and high peak pressures versus normal plateau and high peak pressures. And how do you distinguish? Well, if you have anything that's affecting your lung parenchyma, the lungs itself, you're going to have, of course, a high plateau pressure. But of course, as you saw, the peak pressure is on top of that. Your peak pressure is going to then be high as well anyways, right? So anything that's affecting the lungs compliance or the chest wall's compliance is going to result in both a high plateau and a high peak. Versus if you just have a high peak pressure, then that would be purely due to inner airway diseases like bronchospasm, mucus plugs, things like that, okay? That's how you can kind of distinguish it conceptually.
This is a really important list for you guys to kind of really familiarize yourself with. This is a guaranteed at least 3 to 5 questions on both, I think on every exam.
Yeah.
Boards, AKT, IT, all of them.
And if you understand the concept, then you can really, you can just kind of guess, okay, where would I expect to see bronchospasm? Or where would a pneumothorax fall? Would I see high peak and high plateau? Or would I see high peak and normal plateau? Okay. We are going to go to the respiratory rate because compliance is a very interesting subject because it's actually very similar to peak and plateau pressures. So you have 2 types of compliances. You have your static compliance and your dynamic compliance, right? Static compliance is just like plateau pressures. It only takes into account the compliance of the lung and the chest wall. And that's normally about 40 to 60. And this is what you're commonly looking at on the vent. And then dynamic compliance takes into account not only the chest wall and the lungs, just like peak pressure, it's taking into account airway resistance, chest wall motion. So when your chest is moving, and your tissue elasticity. So your compliance when your lung's in motion is going to be lower than when it's still, okay? Not moving air, okay? So static compliance is like plateau pressure, like air's not moving. And then dynamic compliance is like peak pressure, when airway's moving, when air's moving, you've got wall motion, things like that, okay? All right, I am going to end it there. Any questions that you guys have at this point? Hopefully that was helpful. Hopefully you guys felt like that kind of gives you a better idea of all the different settings that you're using and the reasons behind it and the logic behind it. Yeah, what's up?
Real quick, are those equivalent quantitatively or just conceptually? Static compliance and plateau pressure increases. Does that make sense?
They're not equivalent quantitatively. Okay. It's more of a qualitative idea because, right, one is with airway movement, your peak and your dynamic compliance. One is without airway movement, which is your plateau and your static compliance, right? So they're not
the same number,
but they're the same idea, right? Because it's one. If you have compliance issues affecting your lungs, you're going to have issues with both your plateau pressure and your static compliance, right? But if you have things that are affecting the airway, that's going to affect airflow. You're going to have things that affect your peak airway pressure and your dynamic compliance. Okay, makes sense? Any other questions? Sorry we had to rush through it, but...
I like the slides. It doesn't have like a billion lines.
Right.
That was really clear.
And if you guys want, I think they sent out the PowerPoints to you guys. I have in the notes like all the descriptions of all the things we talked about and some of the things we missed, and it can go into a little more detail too. So you guys can feel free to download the PowerPoint, kind of mess with the ventilator and get comfortable and read about all the different things that you can use it for. All the tabs aren't fully finished, but a lot of it is, and I think it can be really helpful. All right, so email me, text me, if you guys have any other questions, but also during the PBLD, you guys can ask anything with Kukrija as well.
This is a dense topic, so you're going to learn. This is just to try to get you comfortable so that you can be independent in a few weeks. And so there's a lot more to learn than ventilators, which you'll learn as you go through your residency.
Thank you.
Thank you.
Great run. Okay. All right. I gotta find out where I'm going with that.